Written here is the mass of the Earth, 597200000000000000000 kilograms. Absolutely ridiculous number to try and manipulate, to do math with, or even to tell somebody. There's a better way to do that, and that better way is called scientific notation. And the way scientific notation works is you take the important numbers, we call them the significant figures, 5.972. Now you can see this is a small number, 5.97, it's almost 6, much smaller than that number, but it's got a lot in common with it. It's got everything but the zeros. And if you were to multiply that by 10, that would turn it into 59.72. If I multiplied it by 100, which is 10 squared, it would turn it into 597. And all I really need to do is multiply it by 10 a whole bunch of times to turn it into the actual number that it's supposed to represent. So I'm going to multiply it by 10 24 times. And when I do that, we call this scientific notation. So in scientific notation, you take the significant digits, you only put one significant digit before the decimal place. You put the other significant digits after the decimal place. You then will have an exponent that you raise 10 to, and that exponent represents the number of places the decimal would have to move from here to get all the way here. Now this is a realistic example. I'm going to do a couple more smaller examples just to help you understand this. Okay, so now consider this number here. So I've got, that's 120,000. To write this in scientific notation, the first thing you do is write the significant digits. It's a 1 and a 2. And then you'll put a decimal after the first significant digit. So that's 1.2. Then go times 10. And now you see the decimal is here and has to be moved 1, 2, 3, 4, 5 spots. So I'm going to put a 5 as my exponent. 1.2 times 10 to the exponent 5 is scientific notation for 120,000. Would you like to see another example? Well, if you don't, just stop the video. I'm going to do another example. So let's say we have 323000000. Okay, let's figure out what number this is. That would be 323 million. In scientific notation, write the 323 and put a decimal after the first number. And then have a look and say, well, if a decimal was there, how do I move it all the way to here? I would have to go 1, 2, 3, 4, 5, 6, 7, 8 spots. So that is 3.23 times 10 to the 8. Okay, now let's look at this the other way. So what if we were given scientific notation to start with? So let's say we were given 3.24 times 10 to the 7. How would I write that as a decimal number? I've got a 3, a 2, and a 4. And if my decimal was here, I'd have to move it 7 spots. 1, 2, 3, 4, 5, 6, 7. It goes there. So let's put the decimal there, and then we got to fill all these in zeros. So don't be tricked. That number 7 does not mean I have 7 zeros. It just means the decimal moves over 7 times. A couple of the moves were to get past the 2 and the 4. Now, scientific notation also works for very small numbers. We just use a negative exponent. So, for example, let's say we've got, sorry, just trying to zoom in here. There we go. So let's say I've got 0.000017. I'll write that as 1.7, but now that decimal has to move 1, 2, 3, 4, 5 places the other way. So that's times 10 to the negative 5. So if it's to represent a tiny number and you're moving the decimal to the left, you put in a negative. If it's to represent a large number and you're moving that decimal to the right, you put a positive. So this example here, 3.23 times 10 to the 8 was actually 323 million. And in this example here, 5.972 times 10 to the 24 is the mass of the Earth, which is 5972, and then all of these zeros after it. The important idea is if you're moving that decimal from between the 5 and the 9 over to the right by 24 spots, you put a 24 as the exponent of the 10.